Alright, welcome back, Physics 30. So this is the next video in the V1, V2, V1.1, 1.2 series. So I left you with, we looked at two vectors that form a right triangle, and we're about to look at this example. Hopefully you had time to do it. So in this one we don't need to use a ruler or protractor because we're going to use a Pythagorean theorem and trig to figure out what's going on. So I can draw this vector first. So going south, so that's D1, and it is 15.5 kilometers. And then from there, I'm going to go west, 11.5. So those are the two parts, or as we'll see, components that make this up. So south, west, so we know our vector is going to be pointing in this direction here. So I could have just drawn the vector first and break it down into D1 and D2, or just simply draw it like this. And I'm going to be looking for this angle eventually, and also this side. So southwest, it's pointing that way. So of course, to figure out dr, it's just a case of d1 squared plus d2 squared, and then taking the square root of all of that. So in our case, d1 is 15.5, d2 is 11.5. and then take the square root of all of that. I think I get 19.3 kilometers. Then of course over here, the opposite side, over the part that makes up the angle, that isn't the hypotenuse, adjacent. So tan of theta equals opposite over adjacent. So in this case, my opposite side is 11.5. My adjacent side is 15.5. So of course, if I'm looking for the angle, I have to find the inverse tan of that, and that's going to give me 36.6. Be careful, make sure that your calculator is in degree mode, or DEG, because if you're in a math class, you may have been using radian measure, so just be aware of that. So therefore, the final answer, dr, is equal to 19.3 kilometers. And of course we have that 36.6. Now to state the direction, we went from south and moved east. So south and moved east. Now if we had drawn it the other way, if we have drawn this one first, it'd be west so many degrees south. So it would just be 90 subtract that. If I take 90 subtract that, it would have been west 53.4 degrees south. So either one, you only need to have one. So you could have had either one of those, and then you'd have the right answer. All right. All right, so we dealt with vectors that are linear, vectors that form a right triangle. What if we have two or more vectors at various angles? So even if the vectors are not at right angles, they can be added graphically using what we refer to as a tail to tip method. That's kind of what we're doing here. Like we add one vector, head, so start to finish, then from there, start to finish. You just keep adding them on, basically. And then the resultant is from start to finish. So of course, start to finish is from the tail of the first vector to the tip of the final vector. So you have so for every vector, you have a start, which is a tail, and then over here we have a tip. Okay, so if we had these three vectors, 1, 2, and 3, V1, V2, V3, so I could physically move them as long as I maintain their magnitude and direction. I can move them however I want. Okay, so if I look here, I'll draw, so if I start here, vector V1, there it is. Then from there, vector V2. Then from there, vector V3. And I finish here. So starting there, finishing there. So that means my resultant will be from the start to the finish. So that vector right there. So then I can draw it. And of course, I have to use an appropriate scale to do that. So if you look at the next page, we'll do one of these. And so we have 3 here. So to find the resultant, we're adding up all the vectors. And again, it's not just 24 plus 40 plus 32. Even though we write vector addition as that, because those half arrows, we know that's actually vector addition, not scalar addition, not just simply adding the numbers. We have to take direction into account. So if I look over here, I'm going to have a scale that satisfies each. So scale 1 centimeter. All these numbers here are divisible by 8. So if I made it 8, if 1 equals 8, then to draw this one, to draw something that's 24 kilometers, of course that's times 3, so I would make it 3 centimeters. Okay, if I was making my one that's 40 kilometers, let's see, that's times 5, so I would draw this one times 5, so 5 centimeters would equal 40. And then to draw that last one there, to draw something that's 32 kilometers long, that's of course times 4, so I would make it 4 centimeters long. All right, so now that we have the scale and we know how long we're going to make it, so we're going to make V2, let's see, the 24, we said it's 3 centimeters, so we're going to make that 3 cms. This 41 we're making 5 cms, and this one we're making 4. Doesn't hurt to do that just so you know how big to make it. Now the next thing we have to do is where to start on our piece of paper, because we don't want to run off. So we're going south, then southwest, then west-north. So south is this direction. So we're going this direction. Then from there we're going southwest. So south and go west. So we're going to go that direction. Then lastly we're going to be going west-north. So we're going to be kind of going like this. Down, this angle, and ending up here. So obviously don't start over here. Maybe we'll start over here somewhere. All right. So we'll start off by drawing our 2 axes. Okay, then line this up like we did in the other video to make it 90. And for here we're going straight south. And 24 kilometers is represented by 3 centimeters. So we'll make it 3 centimeters long. So draw that, put our arrowhead. Now, from there we have to draw another coordinate system here. We have to draw another one because this is our starting point of our next vector. So I could have extended that. There we go. And from there we're going southwest. So this is going to be where my 0 is on my protractor. So let's see. So there's my 0. So pointing straight down is 0. And I'm going to tilt it so I'm going 30 in the west. So 10, 20, 30 is right there. So let's make a little dot right there. And this vector I want to make 5, because if 1 is 8, then 5 is 30, or sorry, 40. There we go, 5 is 40. So I'm going to make that 5 centimeters. Make sure you use the centimeter side, not the inch side. So there's 5. Oh, almost was at the point I wanted it to be at. So 5 is there. So my V1, my V2, and I should show this angle here. That was my 30-degree angle. Okay. Now from there, I want to do my next vector. So again, draw the little Cartesian coordinate system here. And draw the vertical part. There we go. And this time I'm going west-north. So west-north, that's of course quadrant 2. So west-north, so I put my 0 of my protractor on there. So west, and then from there go 52 north. 10, 20, 30, 40, 52 is about right there. And this vector I'm making 32, which we represented as 4. So this started a random number, orientated so I go through that direction. 1, 2, 3, 4 is right there. Good, so that is V3. And west, going north 52. So this is my 52-degree angle right there. All right, so I've drawn my 3 vectors. And now from there, so I started here, start, finish. So my final vector, of course, VR, is from start to finish. So from start to finish. Right there. So your finish should have the arrowhead. Now since I've drawn it like this, it likely is convenient. Now I can see this is a quadrant 3 vector, right? So if I draw this, we know it's in this area here. So I could go west, south, or southwest. It likely makes sense to go southwest because it's already drawn that way. So if I make my south 0, then I can take a look here. 10, 20, 30, 40. Oh, looks like it's going to be 50. 50.0 right on the nose. And then, of course, if I measure this, again, use the centimeter side, it looks like it is 6.5 centimeters. So therefore, VR is equal to 6.5 centimeters, which of course is, if 1 centimeter equals 8, then 6.5 will equal, well, you can see I'm going to have to multiply by 8 to go change from centimeters to kilometers. So 6.5 times 8, 52 kilometers. Okay, because that makes sense, right? If 1 is 8, then 6.5 is 8 times bigger. And for the angle here, I started south and moved west. So started south and moved west, and of course that amount that I moved was 50 degrees. So that is VR. And of course if I wanted to measure this angle instead, I could. And 90 subtract 50 is 40. It would be west 40 degrees south. But of course you only need to have one angle. All right, so I'll have you try the final example on there and see how you do and come back to the next video. All right, we'll see you again.